Seems off. Oh well, I'll live with it. Hello, glad to see you. It's always that there's a few of you who can join me for the live stream. That's always very much appreciated. Um, just nice to be talking to someone who's in real life out there. So this is week 13. That means that we are coming up on the end of the third project cycle, which is due on Sunday. I'm going to do some more work on Project 3 myself, which when I do that tonight for me means that I have been demonstrating Project 3 ideas to you for a month now, or this is the fourth time. So I hopefully have given you ideas that you can use to implement your project, and I really, really hope that most of you have decided to start long before now. I've done it myself as a student. There were occasions when I waited till the last moment, and I always regretted it. Didn't always stop me from doing it, but I certainly always did regret it when I did it. Which is why I kind of just hammer away at it for you guys, because I know what stress that can cause. But we all make our own choices, so there you have it. Next week for us is a normal week in terms of content, so I will do a live stream on Tuesday night. There will be a lab discussion, homework as always. I know there's a Thanksgiving break day in there, but at Butte College we only actually do the Thursday and the Friday, so I will do as I often do during the live stream, which is I will give you a lot of help on the lab, so hopefully the lab won't be burdensome to you, but at least you will have Project 3 in your rearview mirror, which for me means that during whatever I have for Thanksgiving, I will be grading projects. So I hope that there are some interesting ones, because that will make my life a lot less to not look forward to. I will say it kind of backwards. Okay. In terms of the labs last week, so everyone who submitted one just did great. So hopefully that means that either you know what you're doing and you just kind of do great on your own, or you're watching the live stream and using the help that I offer, or doing the reading, or some combination of the various things that you have. But everybody who's turning in work is doing great. So I always kind of hope that there's someone out there who has decided to watch the lecture for the first time, or at least the first time in a while, who will be reminded that I do my best to offer you a lot of assistance on the things that I ask you to do. So anyway, if you know of people and you can get the word out and help them that way, then I'd appreciate that. But otherwise, there's nothing really to say or show about Lab 12 that was unit tested, and they were all the ones that were submitted were great. I had a handful of people in one section just not turn anything in, and it may be that they just find themselves very far behind for not having basically put any effort into the class, and I wish there was something I could do about that, but there isn't. Okay, so week 13, so just so you can see where we're at down here. The project is due this Sunday along with the normal work for the week. I have been doing things on the project since week of October 24th. So this will be the fourth week that I do some Project 3 work during the live stream to give you ideas. And then we head toward the finish line starting next week. So that's where we're at with that. Let me walk through before we do any kind of looking at code kind of stuff. So we're going to do work with strings. Why? Well, in part because strings are just kind of a weird, complicated, difficult thing to deal with in computer science. There's a variety of reasons for that, but just know that we love integers, and we're okay with floating point numbers, and we're okay with characters and Boolean values, but strings are complicated. For a variety of reasons. They can be long. There can be lots of text in a string. They can have lots of weird symbols in it. When we're getting user input and we want it to be text, the user can do weird things with upper and lowercase values. We do a lot of work with strings. If you've ever submitted a form on a website, as an example, or if you've ever tweeted, or if you've ever given feedback to done something in social media, you have delivered strings of data that someone's software has to deal with. Right here in Twitch, for example, there is a software bot that monitors the chat, and it looks for key terms in the chat, and it flags comments that contain what Twitch by default considers offensive terms. The other day, someone used the appropriate computer science term for a dummy declaration, and Twitch flagged the word dummy as being potentially offensive. But that's because the people who wrote the software actually were working with string data, and they were looking for patterns in the strings. And they had to account for the fact that sometimes someone might put an offensive word and capitalize it, or, upper and lowercase the letters down it. So that's a lot of way of saying that it's worth the trouble to learn what you can do with strings, especially when you are learning a new language like the Go language, which is new to you, most of you anyway. What can you do with strings in this language, and how easy or how hard is it? So that's why we're doing it. It's important in our line of work that we understand the complexities of strings, the things that strings can do that make our life more difficult, and then the ways that we have to manage and manipulate strings in our language of choice. We're also going to add, we're going to keep using slices. So we're actually going to do some algorithms where we take slices of strings and we do manipulations on the entire slice. I'll try to build up to that so you can kind of see how we get to the point from doing something to one string to doing something with many strings in a slice. And then the last new thing is nil, which is a way in Go language code to represent an as yet non-existent slice. This nil value is handy because we can write code to look for that value, which then informs us in terms of decisions we make and the logic we write in our code, and what actions to take. So strings and nil. I'm going to open up the strings one. Hopefully this is the official documentation. Excellent, it is. So homework as always, the lab, which I guess I will, yeah, let me just pop these things open and I'll come back to them later. The lab is unit tested this week. So I know I've written a lot of narrative in the discussion. I can tell that some people read my discussion prompts and other people just throw in there whatever they want because I guess it's not worth their trouble to do anything to learn something. But the prompt is here because I think it will assist you in understanding the point of the discussion. We are setting up as we approach the end of the semester here. Some of you are going to go on to take other programming classes, and if you do that at Butte College, then you are going to take your next class in C++. If you go to Chico State, you're likely to take your next class in C++. So during our last week, we look at C++ code, and in discussions from now until the end of the semester, we will regularly look at, for the purpose of comparison, the Go language and how it does things versus the C++ language and how it does things. The reason for this is because there is no reason to have anxiety about using a different programming language. Go language is so much like C++, cleaner and better in my opinion in some ways. It's so much like C++ that you will find that all of your skills translate very well into C++. So that's why we're doing these discussions, is because I want you to understand that you should not be intimidated by a new language coming your way. And then a reminder, so homework lab and discussion as always, and then project 3 due on Sunday, which I will regret when I get to next week, but that's my trouble, not yours. But I do hope that I get to see some interesting implementations, because that's where I can get some joy out of it, is seeing your progress and what you are able to do with the skills that you've accumulated by all the hard work that you do in this class. Okay, I already opened the lab stuff. Yeah, so I'm going to go look at strings first, and then I'm going to make a REPL and play around with some string functions. We've looked at this before, so this isn't entirely new to us, but I do want us to continue practicing reading documentation like this and understanding what to do with these things. So let's just take, I'll just take one toward the top. Okay, so count. I'm going to click on this. Count. Count counts the number of non-overlapping instances of substring in S. So when it says, when you see weird stuff like this, substr in S, look in the parameter list and you will see, oh, if I give it a string S, which you could think of as the haystack, it's going to look for substring, needle, if you will, in the haystack. So this is the needle that I want to look for in this haystack. And what it tells me is, that's interesting. If substring is empty, it's just going to return the number of characters in the string +1, which is weird. But anyway, it's going to return an integer. So I have to give it the haystack string, I have to give it the needle string, and I have to then be prepared to receive an integer that represents the count of how many times this needle exists in this haystack. It's also the thing I need to note that it's in the strings package, which means when I use this count, I will have to import strings, and then I will do strings dot count. There is an example. So they've imported strings and strings dot count, she's and e. Now they're just printing out the results directly, and we're not going to do it that way, because I think not doing it that way might make it easier to track what's going on. So you said 20, 13. So count. So I am going to put a string in here. I'm going to get rid of this hello world. So just to practice, so I've read count. I have to give it an S, which is the haystack. I have to give it a substring, which is the needle that I'm looking for in the haystack. And then I have to be prepared to receive an integer, which tells me how many times did that needle appear in that haystack. And I'm actually going to name them that way. So I will say, yeah, good one, Kevin K. Kevin K in chat is pointing out that the examples are nice to see in the Go documentation. Most of the time you find examples, not 100% of the time, but it is very nice when there is an example, and you can even alter them and run the code right in the documentation, which is a pretty slick thing. Okay, so let's make a haystack. Apples and oranges. Let's just say apples and oranges, and let's look for the needle. Apples and oranges and having to come up with fruit names. Thank you, bananas. Thank you, Kevin K. Okay, so let's do a needle. And the needle can be as little as one thing. So how many A's, in other words, are in here? So here's 1, 2, 3, 4, 5, 6, 7. So I'm going to count equals strings dot, is it string dot count? Strings dot count. I have to give it the S part, which is the haystack, which is how I remember how it works. The substr, S-U-B-S-T-R part, which is the needle, the thing I want to find. And then what it's going to send back to me is how many times does that needle appear in that haystack. So we can print all that out, in fact, by saying this thing appears this many times or not in this thing. So the needle appears the count number of times in the haystack. I'm going to add some more symbols in here. So let's put single quotes around the needle. Ooh. Come on, man. There we go. Okay. So what I anticipate is it will say A appears 7 times in apples and oranges and bananas. That's what I think. Okay, so there it is. I should have put a new line there because it looks cruddy. Okay, that's what I expected. So what happens if I change the A in a few places? Probably everyone knows what is going to happen. Now it only appears twice because it will only count the ones that match the case. So this is one of the challenges of strings, is that you have to account for the fact that people might capitalize and upper and lowercase things in all kinds of weird ways, especially in our social media world where people do this kind of stuff all the time. So I'm going to go ahead and add the code to fix this problem. So how do we fix the problem that I want to count all the A's and I don't care if they're upper and lower case? Well, the strings has something to do that. In fact, it has two somethings to do that. So when we are processing strings, we very often need to make everything all uppercase so that it doesn't matter how it was spelled in terms of capital and lower letters, or we make everything lowercase. It doesn't really matter as long as all of the things are the same. If they're all uppercase or they are all lowercase, it's the same. So this function to lower. Yeah, you're exactly right, Kevin K. So to lower would make them all lower. To upper, where did it go? Oh, it's right here. We'll make them all upper. And the thing again, if we just click on to lower, so to lower returns S, which is the string that you give it. So if I give it a string, it will return a string. So how can I use that? Well, I can do it in a couple of different ways. So I can say lower haystack, for example, equals strings dot to lower haystack, and lower needle equals strings dot to lower needle, and then I can run the count against the lowercase version of the haystack and the all lowercase version of the needle. And then I'm going to do a little trick here, because this code, the user sitting at the screen doesn't need to know that I did this little trick. They don't need to know at all. So I'm going to not show them that I did this. In fact, I'm just going to show them their original needle they were looking for and the original haystack. Even though I know what happened is in the meantime, I actually pulled a trick and I forced everything to be lowercase. So it looks like I didn't change anything, which I didn't change the originals, but in reality, I changed things for the purpose of doing this count. Most of us programmers would probably not add these extra lines. What most of us would do is, understanding that lower haystack is really just a consequence of doing this to lower thing, we would just do it right in place. So the string we plug in will be the result of to lowering haystack. And we do this same thing also for needle. I'm getting up toward the end of the screen here, so I'm still okay, but I need to start being mindful of how far over to the right I go. So they still will never see that I did this, because this does not make a permanent change. It's just what I plug into the function is to lowered for the haystack, and what I plug into the function is to lower the needle. But I never, since there's no equal signs going on anywhere around here, The original haystack and needle remain unaltered. So there they go. Let's count the, let's look for ANs, which should be, here's one, wait, 1, 2, 3, 4, non-overlapping, 5. So there should be 5 ANs. So you get the idea about count, I think. And also being mindful of either to lowering, or if I wanted to, I could make them all to upper. It doesn't matter as long as the comparisons. Sometimes we do want to be case sensitive, meaning we want to respect the original spellings. But often we want to be case insensitive, which is a lot of people's expectations anymore. So when I say case insensitive, I mean I'm slamming the strings all up or all down. If I say case sensitive, then I'm going to respect the original spellings. This is a case insensitive count. Okay, so yeah, I'll just leave that code. So let's toy around with some other ones. That was count, and we also got to try to lower and to upper. Contains. Reports whether any Unicode points in chars, that's interesting, are within S. If you wanted to find, say, A or N, you'd just I'm not sure if I get the comment, Kevin K, so maybe you can give me a little bit more context to work with. So this contains any I'm not going to experiment with, but basically you give it a needle, and now the haystack is looking for any one of or some combinations of. So I could do, well, I'll go ahead and do contains any. What does it return? It returns a bool. So if I give it a haystack and then a set of chars in a string, it will tell me true or false whether or not any of those appears. So let's try that. While we're at it, I'm going to comment these things out. That's fine. I'll leave needle and haystack. So I'll make a result equaling the strings dot contains any. So I give it the haystack, and then I say, does it contain any of these characters? X, Y, or Z. And then I can say if the result is true, put some quotes around that. Why I hate that thing. Going to plug those in like that. Else uh-oh. There we go. XYZ first this time, haystack second this time. So hopefully everyone gets the idea. The contains any just looks for these individual letters. I should get a false here. Needle declared but not used. So did not find any. So it's just looking not for that pattern, but for any one of those letters. So if I were to say XYZ and little o, I'm not being case sensitive this time. So yes, it contains at least one of X, Y, Z, or O. This would have been a good chance to use a variable for that. This is a case sensitive check. I respected the original spelling and just gave it some letters. All right, so there's a contains any. And the idea here is that I'm going for is simply to show you these things in application. We can also do a contains, where we look to see if a not individual characters contains any of these characters, but contains this entire substring. We counted substrings. We can cut things. What do you get before and after? Ooh, you get two strings back here. Let's do a cut. So if you do a cut, you get a before and an after and a found. How interesting. You get three things back. Let's try a cut. So you give it a string and you give it a separator, and what it does is if it can find this thing in the haystack, it will give you everything before it and everything after it, and it will give you yes or no, it even found it in the first place. So let's look at an example of that. So this is really just how do you read this documentation and use stuff. So this one is quite interesting. Let's make a new, let's just call it a data point or something like that. Equals just made it up. So how does this work? So I'm going to get a before and after and a found. I get three things back from this function. Strings dot cut. What I'm cutting is the data point, and where I would like to cut it is right around that thing. And then I will say if found equals true, found. Let's make the separator so I can plug it in better. Separator, so found, found that separator, and then we're going to have the before and then the after. Let's see what that looks like. So we have the, so I know whether or not it was found, so I use that. Here I can say, so this is data point, did not contain a separator. I'm getting pretty close to the edge of the screen, but not there yet. Let's see what happens. What? Didn't find strings.cut. What are you talking about? That's very peculiar. I'm looking to see if I made a mistake somewhere else. Strings.cut not found. There must be a mistake that I made somewhere. That's weird because it's right here. So my guess, I mean, I'm unhappy about this. Strings cut. It's right there, strings cut. It's possible that we have a version of Go that doesn't have this in its libraries. Strings.cut. It's right there. It's right there. Well, that's a bummer because that was going to be a fun one to run. I'm just double checking myself, and I trust myself that I got this right. And it won't compile. So in this case, Well, what's happening is the Go language version on here undefined strings.cut. That is so odd. My guess is Go version 1.17.5. Yeah, very peculiar. It's not telling me that the arguments are wrong or anything. It's just very strange. Strings.cut. Before, after, found. Yeah, that one's just not going to work here. Man, I put a lot of work into that. I'm very, very unhappy with that. But it doesn't work. So if this should happen to you, I mean, you might sort of ask me to help you double check, but let me purposely make a mistake somewhere. Yeah, it just doesn't work. That is so strange. Well, that's a bummer. Why doesn't cut work? I don't know. What version? This is 19.3. So this is possibly new. The Replit is using Go 1.17. Can I change the version? Oh yeah, look. There's no cut here. Oh man, well I'm going to stay on this version. No, let's do this and make sure that we can find. All right, so cut doesn't exist yet. Well, what do you know? Let's keep going. Has prefix, has suffix. I think we've done those kinds of things before. We can do one real quick if you want. I'll just do it here. So result strings dot has prefix. Let's do has suffix. Data point 27. That's just looking for some pattern at the end of a string. So is that pattern exist? Oh my gosh, leave me alone, REPL. Okay, so as expected. So you can check to see if a string, this kind of thing, by the way, is useful for stuff like this. You can do stuff like this, right? So you can look for file extensions and the like. All right, we're probably starting to get bored of me doing just these. You gonna run or what? Yeah. So anyway, just again, I did have suffix, so let's go read it real quick. So has suffix tests whether the string s ends with suffix, and then I realize that I need to be ready to receive a true or false as a result, and then I use that in my code. The result being true or false to know what to do next. So it takes practice. What else did I list that I wanted to try out? Contains, trim, join, split. Okay, so contains, maybe I'll do. Well, I did something similar to contains. Let's do a join. Well, let's do a trim first. So there are several trims here. There's a trim, there's a trim left, there's a trim prefix, trim right, trim space. The one that I use a lot is trim space. So trim space returns, it says a slice of the string S, but what it really means is a subset of the string S with all leading and trailing white space removed. So if I give it an S and it has any spaces on either side, it's going to return it with the spaces gone. So let's do a trim real quick. So we'll do a messy string. This is the kind of thing that we do a lot in like web programming, because we never know if people are gonna like hit the space bar or hit tabs in weird places at the beginning, at the end. These are the kinds of operations that we lean on a lot to kind of clean up the data that we receive through websites and stuff, and many other places. So we'll just put a whole bunch of spaces, and then we'll say, hello, I am messy, a whole bunch more spaces, and then we will say clean string or trimmed string equals strings dot trim messy string, and then we'll print the result. Messy string and the trimmed string, and I put quotes around it, so we what am I supposed to give it? Oh, trim space. I wanted trim space. I noticed, by the way, so I went through this kind of quick. I give it an S and I get a string back. So I give it a string, I get a string back. And then I can use that information in my output. So there's the messy string. I put single quotes around it so you can see all the messy spaces around it. And then here it is all trimmed up with all the extra spaces kind of chopped off the ends, which is a common kind of cleanup. So that was what I just, a trim. I did a trim space. A join. So let's look at a join. And then a split, and then we can look at the lab and then do some project 3 stuff. I've got an idea. Let's do a join. Oh, I see. Okay, so in chat, Haley's asking, what if I wanted to look for more than one needle in the haystack at a time? So there's 2 answers to that. Contains any won't look for a pattern of characters. It just takes all the characters that you give it and contains any, and it looks for the individual characters and just tells you, yes, I found at least one of these in there. Contains, I can do one here. So I can say, I'll reuse, I don't have a result anymore. So result equals strings dot contains, and let's just say the trims string and mess. So there is no way to add more to this. So for contains, you can only do one thing at a time. And it's going to look for this entire combination. MESS. So contains looks for the entire combination. Contains any will just kind of look for the individual characters to see if they're there. So if you need to look for mess and something else like hello, you'd have to do it this way. And then you could say if result equals true and result 2 equals true. So hopefully that was a good idea, Haley. Thank you for that comment. This would be how you would look for the whole patterns. If you needed to test for more than one pattern, then you have to test for both of them separately and then do what you want to do accordingly. I'm just going to do this one quicker. So it should be true. So both patterns are present in the string. So mess is there, hello is there. So that's, if you needed to look for patterns, not just single characters, that's how you'd have to do it. So thank you for that. Good ideas in chat. Okay, so, I was going to do, okay, so next is join. So join's interesting because I give it elms. So concatenates the elements of this slice to create a single string, and then it places this separator between them. So this one I have to give it a slice and a separator, and I get one string back with all the stuff kind of jammed up together. So let's make a slice. We'll say, I'll do colors this time, equals a slice of strings, and I will make them be red, green, blue, orange, purple, and then I will say joined equals strings dot join. So I will give it those colors, and I say, I want them to be joined together with a little arrow. Interesting, that's taken a while to build. Turns out that is super, super handy. So there's join, and then we can also split. So remember with join, I looked at it, so I give it a slice of strings and a separator, which will be used to join them together, and then I get back the one whole string. So let's look at trim, and then we can look at the lab. I think not trim, split. So this one goes the other direction. I give it an S, slices S into all of its substrings, separated by some separator character, and then I get a slice back. So for split, I would start with, let's make some animals. I start with a whole string, so giraffe. Let's use exclamation points. A giraffe, a lizard, alligator. Wait, not two of those in a row. An ant. That's not an animal, technically. An eagle. A dog. A rhino. Thank you. That's cool. Rhinoceros. Okay, so there is the all smushed together ones. Now I will get the list of animals. As a result of calling strings.split, I will give it the original animals, and I will say split them everywhere where you find the exclamation point. And then here I'm going to do the testing output, just the default of the list of animals, and we'll see if it succeeded in splitting those things apart. This is super, both of these things are super, super useful. If you've ever seen a comma separated values file as an example, then you can imagine, I think, an application of this. So we deal in data like this a lot, where it's kind of communicated, kind of all mushed together with some character separating the different parts of the data. So there it is, kind of split apart with the exclamation points taken out. Quite cool. And then I'll just sort of seed. We can let's do it here. So I'll leave this idea for when I load up the lab here in just a second. So I'm going to range over the list of animals. So for I'm going to call it animal in the singular because I like that. Range over animals, getting a single animal at a time. And we're going to do stuff. So let's do... what was my idea? I've already forgotten. Oh, I know. So print this has a certain number of characters in it. So we will print out the animal, and then we will print out the length of the animal. So it turns out that I am using the animal that I get, but I'm not using its index. So I'm just going to get rid of that. So I'm going to print out each of the animals, and I'm going to print out the number of characters in that string with the length function. And this will kind of seed us loading up the lab. What? Oh. List of animals. Wrong thing. So down here at the bottom, you can see giraffe is 7 characters, lizard is 6, eagle is 5, dog is 3, rhinoceros is 10. And I just want to put this in our head when I go get the lab code, because loops give us the ability, loops in conjunction with all these string functions, give us the ability to actually process lists of strings performing operation on every string in the list, which is a super powerful thing to be able to do. So let me first let me make sure that I share this with you in lecture. And let me create a new REPL, and then I'm going to go get the code for the lab. Okay, so is this the code? That's the testing code. This is the irregular code. And then let's go get the test. Okay, so there is a main down here, but it's not being used. So I want you to see, just to start, every one of these functions returns nil right now. And what nil is doing is it's representing a non-existent slice. So we're using this nil as a stand-in basically for I haven't implemented this function yet, but I want it to run. So if you have a function that returns, say, a slice, and you want it to compile and run, but you don't want to implement it yet, you can return nil, and it's going to complain that I haven't used strings yet. But anyway, you can run this, and it will run. Let me see what happens if I take one of these out. So you'll notice here that it will say missing return at end of function on line 18. So this function right here says I'm returning a slice, but I haven't implemented it yet. So for our purposes, what this nil allows us to do is kind of mark this spot that's legal code, but not implemented yet. So this nil is legal Go language code. Oh, sorry, Kevin K. I missed the zebra. Maybe I can get that in here in a test in a moment. So anyway, we're using nil to stand in for an unrealized slice, an uncomputed slice. And the nice thing about nil is that it is legal to use in the Go language, and the Go will execute this code happily with this nil stand-in for the non-existent result. So when I took the return out, Go complained at me that, hey, you say you're returning a slice of string, but you didn't. So I'm going to return a nothing, and Go is perfectly happy with that. So notice that every one of these returns a slice, but since we haven't implemented it yet, we're going to use nil as a legal stand-in that Go will accept for that as yet non-existent slice. Same for this function, supposed to return a slice, but we're using nil for a stand-in. We should, in theory, also be able to run the test, even though we're going to fail them all. Let's see if it crashes or if it's happy to just run it and fail me. Yeah, so no crash. I fail every... Oh, no, I passed one. I managed to pass one by accident. 2, 3, 4, 5. So I'm managing to pass a few just by returning nothing, which means that there's probably some cases that nothing is expected. So anyway, this is where nil is in application for us this week. Is it gives us a way to write legal code as a stand-in for a slice when we haven't yet implemented our solution. So I've done that on all of these functions, except for this one, which returns a string, in which case I'm just returning an empty. But the ones that have a slice, I'm returning nil, which is a legal stand-in for a non-existent slice. This one, slice, returning nil. So that's why all those things are there. Okay, so strings of length returns a slice containing all strings in a given list matching a given length. So let's set up a scenario with our animals, and then I'll get... So I'm going to use main to run my experiments, and then I'll do the testing later. So let's do some animals again. This time it's going to be a... we'll do a slice of string. So we'll put zebra in there, put giraffe in there, we'll put lizard in there, put rhino. I'm shortening because that's going to allow me to do something I want to do, and then a dog, let's say. So here's what I would like to have happen. Short named animals equals. So what I want to be able to do is say strings of length. Was that the name of the function? Strings of length. If I give it a list and a length, it will return to me a smaller list containing all of the strings that match the desired length. So let's give it our animals and give it a length of 5. So what I should get back for short named animals is zebra, which has 5, and rhino, which has 5. Now, right now it returns nil, but that should run fumped. I'm using fumped. So it should run, and it gives me a, that's what nil looks like when you try to print it. So that's good, it compiles. So now let's go implement the thing. Strings of length. So how do we do this? Well, we're expected to create a slice containing a subset of the given slice whose strings have a given length. So we need a result slice. Which will be a slice of strings. That will be the thing that we return. And in fact, if we run this code, it will still work, or should. Except for it's going to complain to me about strings. Gosh, go. Okay, so same difference. I haven't done the work yet. But it works because I do make the result slice. I just don't put anything in it. So here we go. Let's put stuff in it. We're going to range over the list. This list right here. So for I will call it S equals range over this list. So the S will be the individual strings that I get. The I's are their indices in the slice. If the length of that string is the same as the target length, this guy, then I want that to be appended to my result. That's it. I don't need the I. I didn't use it inside the loop. I just used the S part, the string part. So I'm going to go through, grab every string out of this given list. I'm going to check the length of each string against the target length, and if they match, I'm going to append that string S, S, S that I got out of the list into my result. So now we should get zebra and rhino in theory. So there are zebra and rhino because they did match the desired length. Let's do, I'll leave that on the screen for just a second. There was a hint here, by the way, about uses length of string. Now we have a model though. We're going to set up a result slice where that's required. And then we're going to use a loop to look through and do things with the provided slice. Let's do ending with. Case insensitive, keep that in mind, uses strings dot to upper or strings dot to lower, and strings dot has suffix. So I'm expected to be case insensitive, which means I'm going to have to hammer them all uppercase or hammer them all lowercase so that my comparisons work. So let's start by setting up our result slice. And that will be what we return. Let's go set up our experiment. Oh, this is a has suffix. Yeah, this is a has suffix. So we will do a, let's say, call it files. We'll do a slice of strings, and we will have like exam.docx, money.xslx, notes.txt, and paper.docx. That's enough. The function name is strings ending with. Okay, strings ending with. So we will do a docx files equals strings ending with. I give it the list, the files, and I give it what I'm looking for, which is the ones that end in docx. Let's make life difficult because it's supposed to be case insensitive. So let's make it be weird because both of these should come back as the result if I do it right. All right, so now we'll go, well, let's run it and see what happens now. Result. What? Oops. That's a string slice. Okay, so right now it's nothing. Now let's go fill it in with the algorithm. So it's case insensitive. I got to remember that. And I'm looking to use has suffix. Same setup. We will grab a string from the list that we arrange over. We'll grab, of course, each string in sequence. Doesn't really matter what they are, how many there are. It'll just do it. Now we got to do, well, we have some options here. So we could say upper S equals strings dot to upper. Let's do to upper this time, S. And upper suffix equals strings dot to upper suffix. That's this guy. And then I can say if strings dot has suffix. I remember this returns a true or false, so I can just check it for true or false. I'm looking in the upper S for the upper suffix. If that's true, then I can append that S. So I'm going to append the original S, not the uppercase one that I just did to make the search case insensitive. That's what all this to uppering is about. Inside of the loop here, I never use the index part, so I can cancel that out. Let's see if that works. I should get the two docx files. What? Man. So there's the two docx files. That's correct. I can simplify this, or I can make this a little bit cleaner. I don't really need the extra variables. If you're more comfortable this way, keep it that way. But I personally think that this is actually harder to read than if I were to just do this. This is getting pretty close to the edge of the screen. So instead of making the separate variables, I'll just upperify them, the string and the suffix that I'm looking for as I do the check. And if that's successful, then I can append things. And let's make sure it still works. Still works. So that should give you, that thing on the screen there should give you what you need to do beginning with. Has prefix. Let's see if there's any other containing. Case insensitive again. So instead of has suffix or has prefix, this will be contains. Same idea. Ooh. Fields to lowercase. So this one's interesting. I'm still doing okay on time, I think. Separate a string into its fields as defined by the given separator, then convert all the fields to lowercase and return the result. Woo. So I start with a string. I'm supposed to split it apart, split, and then lowerify everybody. Well, let's go set up, well, let's set up our result. So the string slice, which we will return, and now let's go set up an experiment so we can see how this works. I'm going to call it fields. Clumped fields. I don't know. Well, we can go with zebra, which is a mammal that comes from Africa. Let's do a mixture here so that when we to lowerify, we should see some good results. So I'm just going to make it be kind of weird. Because what should happen is they all come back all lowercase. Zebra, mammal, Africa. Stripey. Okay, so there's my setup. Now I'm going to, what I expect to get back is lowered separate fields. And then I will have, what's it called? Two lowercase. So, wait, what? Fields to lowercase. Fields. Why don't I just copy it? Fields to lowercase. I give it the clumped fields. I give it the thing that separates the pieces, and then I get them all back separately in theory. So if I print this, should be one of these things. Which if I run it now should just be nothing. Line 71 is complaining at me. Return result. Okay, so nothing. Now let's go do the work. Okay, so I have to split it, and then I have to lowerify it. So, I'm going to do this differently. So I'm going to use the result. In fact, I'm going to change up my whole thing. Oh no, we can do it all in, can we? No, we can't. Yeah, I'm going to do this all in one place. So result equals strings dot split that S around that separator. So part of the work is already being done for me by Go. Now we're going to do something a little bit different. So let's see, we need to, so this result is going to be a list of all the fields, and now I have to cycle through the result and make them all be lowercase. So I will do I, S equals range over what's now the result of the initial split, but I still have work to do. And in this case, since I have to overwrite things with new versions, I'm actually going to refer back into the result in its original location, and I'm going to lower it. Yeah, lower it. So I'm actually going to take the string as it is, lowercase it, and then replace itself with its lowercase self at the same location where it came from. So this time I am using the I because I need it to go back into the slice and overwrite it. So we should get zebra, mammal, Africa, stripey, all lowercase letters. And there they all lower, mammal. All lowercase letters and all split apart. So that's kind of the idea there. All right, so I'm going to leave you with the challenging one, which may or may not. So makes a new slice the same length as the given list. Makes a new slice. Ooh. Maybe I should help you with this. Makes a new slice the same length as the given list. Okay. That we may not remember how to do, so we're going to use make to be the same length as the given fields, this guy. Done. Converts all of the elements of the given slice, fields, into uppercase, assigning the converted string into the new slice. We've done this before. So we're going to range over the original fields. And we're going to write stuff into the new slice, which will be upperifying the original strings. Okay, now what? I'm going to call this uppered. Okay, so now I have a slice uppered that has all of these original fields, but in their uppercase form. Okay, now what? Then joins them into a new, joins the new slice into a single string with the given separator between the elements. Well, we practiced that. So my result in this case is actually going to be strings.join the uppered guys with the given separator. So that's the original separator. So anyway, these are meant to expose you to slightly more complex algorithms. It's not a lot of code, but they're complicated. Okay, so I can use my animals again for this. So I can say join animals equals joined to uppercase. I'll just copy it. Join to uppercase my original animals. And what do I want to connect them with? Let's do, I don't know, that might look cool. Sure, I'm just, whatever. And then let's see what the result looks like. Result declared but not used. Uh-oh. So you notice the error says no return at end of function. Yeah, I computed a result, but I never sent it back. Oops. So there's zebra and then my little separator, and they're all uppercase, and they've all got their little symbol in between them. Okay, space is trimmed. Make a new slice of the same length. We just did that. Trim the leading and trailing spaces. That's trim space. We practiced that. Assigning the trim string into the new slice. So this one is the one that I will leave. I will leave that one as a challenge for you. Suffix trims, make a new slice. We did that. Trims, the given suffix, that's trim suffix. Assigning the trim string into the new slice. So these all follow the same pattern. Space is trimmed, suffix is trimmed, joined to uppercase. They all follow a similar pattern. Except for you don't have to do this last step where you smush them all together. You just do that and then you're ready to return your result. All right, so I hope that I've left you with enough because I need to stop, leave a couple minutes break in here, and then do my idea to show you for project 3. Which I'll have like a little shopping interaction and a little kind of monster fighting interaction. Okay, so I'm going to put a break in here. I hope that I have given you enough to work with on the lab. If you get stuck on anything on the lab, Canvas inbox. Piazza is a great place to post questions. The best way to do Piazza for help on labs is to ask about one specific function at a time. So let's focus on one function if you are struggling with it and work together to figure out what the solution is on one function at a time. Hopefully it would be true that you might not get stuck on any more than one or two. But anyway, if you struggle on the lab, you can always Canvas inbox me or come to office hours. But I encourage you to try Piazza. Put the function that you're having struggles with, share with us what you have tried that didn't work, and then let us work together so that we all can kind of see a solution come together and then sharing it. Okay, it's 5:11. I'm going to put just a 2-minute break so I can run and get some water, and you can get up and stretch your legs if you need to. So I'll be back at 5:13, and I'm going to do some project 3 stuff to just show you a couple more ideas that you might use for your project. So be right back. Okay, so thanks for sticking around if you're able to. This, if you've already got your own ideas, then I may not have anything that you're interested in, but just a couple more ideas that you might be able to use in your project. So let me create a version 3. V3. And I will share, as I've been doing, I'll just keep, I think I've done it consistently, I hope so, share with you all 3 versions. So all 3 versions, version 1 I worked on over 2 weeks, and then version 2 I did something different last week. So this is the 4th time around. This is version 3. So links to all 3 of the REPL so you can go study the examples, and if you can use them, that's great. So I'm going to not waste time on user interface this time and just do a shopping interaction. So I'm going to set up some user variables here, and I'm also going to do a little monster fight and a little gold drop and that kind of thing. So I'm going to do for So for the player, I'm going to make, let's see, do I need 3 health, gold? What do I want? I don't want gold. I want health. And maybe I'll do a sort of amount of physical damage or something. So let's see. For health, let's just start with 100. For gold, I'll start with 10. And for damage, I'll start with 5. I'm just making these numbers up. I showed you last week that you can sort of create labels for the positions of these items, and it makes your life a lot easier in the future if you do that. So health equals 0, because that's the 0 position that I want it to be in. Gold, I'm going to line these up because I think it looks nice, equals position 1. And then what I can do is, instead of saying player 0, I can say player health, and that's a lot easier to code and remember. And I will say damage equals 2. So we'll do a little shopping, we'll do a little fighting, we'll do a little gold gathering. So there's my player stats. I'm also going to have, I'll call it stats. Also do some player items. In fact, this is just going to be, I'm going to start them with nothing. As a string. So player stats is an array. And the reason why it's an array is because I don't intend to add more stats or append more stats later. I'm just going to work on these stats. Player items, though, is a slice because I want to buy and find items as I play the game. So the first thing we'll do is we will make a little print player info function. We will pass in the stats. I'm shortening it here. Yeah, I could have shortened it here too. Doesn't really matter that they match because they're in different locations, but let's say stats, which is a size 3 integer array, and then we'll do items, which will be a slice of unknown size strings, and then we'll do a printf. Oh heck, let's give them a name. Might as well be brave in my game. So we'll add the name here too. Okay, so here's my name. Here will be my stats, so I'll have this much health. I think, yeah, I'll just say gold. Damage, yeah, new line. And then we will do, so here's where I get to use my little label. So stats, health, which is already a 0 because I stored it away that way. And then I can do stats, gold, and then I can do stats, damage. So you see how this is spilling across the screen? It looks terrible. So the thing I tend to do is look for a good kind of big breaking point, like right here. And that just, you don't want it wrapping. It just doesn't look good and it doesn't feel good. And no one likes it when it just kind of wraps around the screen. So better to break it up into 2 parts. And I found a natural breaking point, which was after that comma right there, at the end of the message part before I list out the details. So let's make sure that we can print my stats. I didn't do the items yet. Let's do that. put a line break here. Probably 2. All right, so I'm doing this kind of quick just to give you the technical information. So this is somewhat complicated looking, but really all I'm doing is I print out the name that's here. I print out the various stats, which is here. And I used my little constant labeling scheme so that I could get, so whenever I need the health, I'm just going to say stats at health and that'll just work. Stats at gold will get me to the right place and stats at damage will get me to the right place. The more complicated section is this items part, but really all I do is I set up a little label, items. There's no new line here. So if there are no items, I'm going to put the words no items. I don't need a new line yet. But if there are items, this needs to move to here. Then I'm going to range over the items and print each item out. I don't need the eye, I didn't use it. So let's just see if my stuff comes up. I should have no items to start. All right, so Boyd the Brave, 100 health, 10 gold, 5 damage. That's where I want them, and I have no items. All good. So we'll do a fight and a shop so you can see how you might implement those. So let's do a fight. Fight monster. And to make this fun, let's have the monster be somewhat randomized. Rand time. So we'll let the monster be a little bit random so that it's more fun. So rand dot seed time dot now dot unix nano. I think that's how that works. All right, fight monster. So what do we need to fight the monster? Well, I'm going to print the player's name, like Boyd the Brave. You do a wrestle the monster, whatever you do. We also need to pass the stats. And here's a little trick. When I need to alter the stats, I have to use slice notation because it's an array. To get around the limitations on editing arrays, I'm going to use slice notation to make the array editable, basically. And then I'll also pass, do you need the items? I don't think we need the items yet. I could pass the items and see if they have a sword. Sure. So if they have a sword, then maybe the fight goes better. Okay, so let's go have a fight. So I'm going to get the person's name so that the output looks more interesting. I'm going to get the stats, which is now being sent as a slice of integer, which makes it editable. And then I will also have the items, which is a slice of string. Okay, so let's see. Yeah, so we'll just do this. Player damage has sword. Yeah, let's do this. So var. Ooh, let's write a function for this. Has item. So I will write a function that takes a slice of items, look for a specific item, and return true or false whether or not we have it. So now I can say var result bool result, and then I can look through the items. So for I item range over the items. If let's be case insensitive. Why we have the ability. If strings dot to upper item is the same as strings dot to upper. Oops, I can't use item because I used item here. Find. Then I have it. So here's a little function that if given the items and a specific item you want to find, it will return true if it can be found, false if it can't, and it's case insensitive. So now when I set up to fight the monster, I can say has sword equals has items sword. And then I can say player damage equals stats damage. And then I can say if has sword. If I have the sword, then I'm going to go ahead and enhance their damage by 2 more, let's say. So now that's my whole setup. I'll check for a specific item. I'll capture how much damage they currently have, and I will enhance their damage if they have a sword. Now we will say monster health equals rand.int n. Let's make them fairly weak so the fight goes fast. And let's not give them 0 health because that would be ridiculous. So now the monster's health will be randomly anywhere between 1 and 10. All right, here we go. We don't expect to get killed here, although we should. No, we'll know because our health will drop to 0. That's fine. Okay, so let's say while the monster's still alive and the player is still alive, let's have them fight. So we can also do, by the way, we can make me hit or miss. So I can say if rand.int n, I'll just give myself a 50-50 chance. So that'll be 0 or 1. So if it equals 1, then I'll say printf, you hit the monster. And then we will take monster health and knock it down by the amount of damage I do, which is likely to kill them. So then we'll immediately right here just check to be sure. So if monster health less than or equal to 0, then we can say you have vanquished monster. You get, I don't know, 3 gold. And then we will take their gold and we will add 3 to it. And then we will get out of this loop. Remember, break breaks the nearest loop. So there's no sense in fighting. This, by the way, should have been if I hit them. Make sure these are all lined up because otherwise I can't tell what goes with what. So all of that is whether or not I hit them. So now they get to hit me. So I'll just say player, stats, health, minus equals 1. They just hit me. Okay, so the monster's going to hit me no matter what. My ability to hit the monster is random, 50%. Because if you do randint n2, you get 0 or 1. So a 50-50 chance I get a 1. Check to see if I took all their health out. And they automatically take health off of me. Yeah, so should be all right. We'll fight the monster, and then we will print the player info again and see what happens, if it all worked. Monster health at end of statement on line 54. What? Oh. This is the Go language. Sorry, I was writing C++ code. I declared but not used on line 35. Fair enough. All right, let's see. So here's the fight. I hit the monster. He hits me back. I have 99 health. Hit the monster. Hit the monster. I vanquish him. I get 3 gold. And then when I print my stats, you'll notice that I did lose the 2 health. I have the gold, and I have the damage. Buying a thing is not that much different, but let's go ahead and purchase an item. Oh, I never used the name. I didn't say. Oh, yeah, I did. Boyd the Brave. I didn't. There. Now Boyd the Brave hits the monster. So let's purchase an item. I don't really need my name for that. I do need the stats, and I need them to be editable because I need to burn up gold. And then I need, I need the item just to check to see if they've already got it. But this is going to have to give me potentially a new set of items. So I may have to update my items having purchased one. And then I might check to see so that I can't purchase 2, although maybe I want to be allowed to purchase 2. I don't know. Purchase item. So I get the stats, which for editing purposes I will deal with as a slice. I will have the items. And then I will return an updated slice containing whatever item they bought. So you could do a little user interface here as an example. So you could, I'll just make a real quick one. So one will be a potion, a gold, I don't know, a hat, 10 gold, should probably let them cancel. All right, and then I'm almost done. So thanks for your patience. If you are watching, if you're watching later, hopefully this helps. All right, so now we will say if the choice is 1, that's a potion. So what I'm going to do here is I'm going to check to make sure they've got enough gold for it. So in stats, gold greater than or equal to 5. That's how much the gold costs. That's the potion, rather. Then I can tell them you bought a potion. And then I do my adjustments. So I will take some gold away from them. And then I will add a new item. Make sure that we got enough gold always. That was a 10. It's a fancy hat. So we take the gold. Let's let there be a damage buff or a health buff. Health or damage buff? I guess a health buff. No, a damage buff. Because the hat just makes you feel more confident, let's say. And then, yeah. Give them that hat. And then at the very end of the function, we have to return the items back just in case we happen to make any edits to it. So this will be shared, so you'll be able to see it. So all I'm doing now is I'm trying out the purchase sequence, and then I'll print my stats to see if anything exciting happened. I'm going to put some blank lines in here. So that it's easier to see the sequence of events. All right, let's try it out. All right, so there's my initial state. There's the monster who had a better run at me because I missed him a few times. Um, yeah, he hit me pretty good. So let's buy a hat. Now a fancy hat, and now you can see that I had to pay for it in gold. I did get the damage buff, and now my items include a hat. All right, so oh, Kevin K, sorry I missed that. Yeah, I could have done an armor upgrade in there as well. But hopefully that gives you guys the idea of how you might do those kinds of things. And by the way, a fight doesn't have to be a fight. It could just be an argument, or it could be, you trip on something, or you lose. So you don't even have to have health. It can simply be like you're carrying around a bag of beans and you trip and some beans spill out, which could be representative of your health. So you can be as creative as you like with the kind of theme of it. Gold can be other things for your game's currency. It could be gumdrops. It could be, you know, bottles of milk, whatever. The damage that you do could be instead interpreted as like you have a lock picking ability, and that sort of can be used to figure out how many locks they can pick or what the odds are that they pick a lock, that kind of stuff. You could also, for the damage, by the way, and then I'll stop, you could make the damage right here. So instead of making the damage be a guarantee, you could randomly maybe guarantee that they have at least one of those, but you could generate a random amount of damage from 1 up to the damage that they're able to do, which probably makes for a much longer fight scene, by the way. Let's see. Unless I get lucky. So how many times did it take me to hit him? 1, 2, 3, 4 times to hit him. You can use your stats to generate random numbers. You can do any number of things. Random numbers are kind of fun because they make the game seem more interesting. Okay, so anyway, I went with kind of a standard theme, which is for a lot of people kind of an easy theme to work with, but you don't have to use the standard theme. I've gotten all kinds of different things. If I were implementing it, and I already know, I kind of have my idea about a person who shouldn't eat too many sweets. And it's probably what I would do. Maybe I'll do it between now and when we do demos, just to have the same experience that you're having. I mean, I've written them before. Okay, that's where I got to stop. I didn't run that much further over my regular hour and a half, so I'm happy for that. So links to the samples from today and the 3 variations that I have showed you for how some ideas to do Project 3, that'll all be on the lecture page. The specific lab solutions I'm going to leave in the lecture video because I'd prefer that people watch that and hear the discussion around it and not just copy and paste code and go. So that's where we're at. Office hours are regular this week. Canvas inbox if you have questions. Piazza for game questions or for lab questions. All that stuff is open. I recommend that if you're using Piazza for something about your code, that you try to limit yourself to 1 feature or 1 function at a time per post. That way we can focus our discussion on that one thing. And then if you have a different issue or someone else has a different issue, we can get a different post about that and discuss it. Okay, thanks for the help with the animals. And it's just been struggling for the creativity part of late. So have a great night. I hope Project 3 goes well for you because it's a lot more interesting for me and fun for me if you get good results and I get to see what your ideas were. So have a great week. Have a great Project 3 sprint here to the end, and I'll see you on Tuesday afternoon next week. Take care in the meantime.